Right. So bitwise operators, like, see, firstly, the bitwise operators are completely different from above operators. Bitwise is nothing but binary level of operation would happen. Bitwise means binary level of operations would happen. Clear? Where we are going to apply the bitwise operators is matter. We are not able to apply bitwise operators in day-to-day life. They will be applied in specific situations. As per my knowledge, bitwise operators are used to perform information security. Information security as encryption, decryption. So wherever the communication of the data takes place between two electronic devices, so when the data is transferring between the two devices, there is a hacker is trying to steal your confidential information that we need to protect. So for that reason, there will be in the network drivers, there is layers we have. There are layers, and they are called, OSI model layers. They are, application layer, presentation layer, session layer. There is a transportation layer. There is a network layer. There is a data link layer. There is a physical layer. So wherever we install the network drivers into the computer or anywhere else, by default, these particular logical programs will be made available in every mobile and computers. Clear? Okay. What exactly happens during the encryption and decryption? Here, there is a presentation layer is the one particular layer where it is responsible. See, this is the source computer. This is source computer. This is the destination computer. The data will be transmitted between them. Yes or no? Here there is a hacker is trying to hack the information. In order to protect this hacking the information, before this particular data transfer over the network, the presentation layer will be doing encryption to your data. Encryption, once it is done, your user ID password will be converted into another form, which is a ciphertext form, which is not understandable to the hacker. If you give vv nayak@cmail.com and password is Hyderabad123, in the network it will go as 0. How a hacker is going to understand? You have given other user ID password, but in the network it will be going as 0, 1. He don't understand anymore. This is how bitwise operators are going to be useful for you to perform the encryption and decryption process. Are you clear? Let's see now. No. What are the operators we have? What are the operators we have? Bitwise operators are bitwise and bitwise or bitwise exclusive or left shift operator, right shift operator, tilde operator. These are the bitwise operators we have to perform the bitwise related operations, right? Let us go with the hands-on. Let us go with the hands-on. Now, clear? Demo about bitwise or operator. Bitwise and operator firstly. Bitwise and operator. Let us take, I'll be taking customer ID. Actual customer ID is that 7799132123 is the customer ID. Password is, let's suppose HYD @123 is the password. Once the presentation layer will do the encryption of this particular customer ID and password, customer ID is become something else, which is 65, which is an ASCII value. Password will become 15. It's an ASCII value. See, it will be tested by the algorithm. Who is going to convert all this? An algorithm will be there. DES algorithm, data encryption standard algorithm, MD5 algorithm, SHA algorithm, Diffie-Hellman algorithm. There will be symmetric and asymmetric algorithms to do all these operations. If you know the network security or information security, I hope you might know this all. Clear? Yes, great. Okay. Now what I'm doing here, I wanted to perform the bitwise OR operation. Bitwise OR operation. What I'm doing? CID, bitwise and password. Clear? ఇక్కడ ఏంటి నేను కస్టమర్ ఐడి 65 కి పాస్వర్డ్ 15 మధ్యలో నేను బిట్వైజ్ అండ్ ఆపరేషన్ చేస్తే అవుట్పుట్ ఏమొచ్చింది చూడు. అవుట్పుట్ ఏమొచ్చింది చూడండి, 1. ఎట్లా వచ్చింది 1? నేను ఇచ్చిందేమో కస్టమర్ ఐడి 77999132, పాస్వర్డ్ ఈజ్ HOD 123, కానీ నెట్వర్క్లో వెళ్ళేసరికి 1 వచ్చింది. ఎలా కన్వర్ట్ అయింది ఇది? 1 చూస్తే అసలు వాడికి ఏం అర్థమవుతుంది హ్యాకర్కి? నువ్వు ఇచ్చింది ఇవి, బట్ నెట్వర్క్లో వెళ్ళింది 1. కానీ ఎలా జరిగింది? Because we are dealing with a bitwise operator, right? Firstly, you have to take the equal binary value for the 65. So 65 binary value ఏంటంటే 1 0 0 0 0 0 1. This is the binary equivalent value for the decimal value called as a 65. Similarly, 15 is that 1 1 1, rest of all zeros. Now we are performing what operation? Bitwise AND operation. ఇక్కడ true and true would become true. True and false. True and false. True and false. False and false. Now this is the equivalent value for this one. ఇలా లోపల ఎన్క్రిప్షన్ అవుతుంది డేటా. Swaroop, do you understand this?
Yes, sir. Yes.
Because directly if you execute, you don't understand how did you get this one. But if you do the operation at a binary level, you will be able to understand that how did you get this particular one. Is that clear? Therefore, it is a binary equivalent operation, we can say, bitwise operations. Clear? Now, let's go to, let's go to another operation. Yes or no? Same operation I'll take. Copy, paste. Instead of and, I'll be performing the OR. CID, bitwise OR, password. Clear? You see the output now? 79. How did you get? Can you write and can you do the bitwise OR operation? Paper book with then change. Firstly, same. The 0 zeros 1 0 0 0 0 0 1 0 0 0 1 1 1 1. రెండింటికి మధ్యలో bitwise OR operation. True or false? True. False or true? True. False, false, false. Operation chain. And kada OR. ఆర్. ఇప్పుడు ఇప్పుడు మనము జనరల్ గా బూలియన్ ఆపరేషన్ చేస్తాం కదా, ఒక ట్రూ ప్లస్ ఫాల్స్ ట్రూనే అవుతుంది. Now, I'll be taking that example. Here, 1. Now, if we do the, what is called bitwise OR operation, what happens here? What happens here? Chained true plus true. And R kada. True plus true. True. True plus false true. True plus false true. True plus false true. నాకు లాస్ట్ వాల్యూ చెప్పండి, అవుట్పుట్ చెప్పండి.
100 1111.
Yes, correct, correct. It is equal to 79 or not?
Yes, sir.
Hello.
Hello.
Right. Swarup, you are trying to say something else?
Nothing, sir.
Yes, so this is the output. So here we are not performing AND, we are performing OR. OR is equal to plus operation. True plus true is true. True plus false is true. False plus true is true. Obviously, this operation, you know, you have done in mathematics also, in set operations. Yes or no? So this 79 is equal, it's a decimal value, but the computer network is going to have this particular value. When the hacker will see this particular value, I think you don't understand that you have given this customer ID and this is password, but the presentation layer will convert into this, and presentation layer will does this particular operation. Finally, this particular value will be going through the network. Hacker never understand what exactly the meaning of this. This is a bitwise or AND or exclusive or any operator will be useful for performing encryption and decryption process. Yes or no? Yeah. Right. So let's go ahead. Let's so let us go with another operator, which is demo about bitwise or operator. Bitwise or operator. Whereas here, demo about bitwise XOR operator, which is cap operator. This operator is called as an XOR operator. The purpose of this operator is that to perform bitwise operation only. But how the logic is going to followed by exclusive operator is that when the inputs are similar, it produces false as an output. Clear? When the inputs are dissimilar, means different, then it produces true as an output. Clear? See, if you look at the switch behavior, electrical switch behavior, when the inputs are going to one positive or negative, the bulb is going to be enabled. If inputs are same, positive, positive, bulb is not going to be enabled. If the inputs are negative, negative, bulb is not going to be enabled. That's how the things would happen. Clear? Yeah. Hello. Clear? So now let's take the same example. What example? Let's take another example otherwise. So now email is going to be converted after the presentation layer. It's going to be a 20. Password is going to be a 12. Clear? Now what exclusive will do? Firstly, it will be convert into binary form. What is the equivalent value for the binary form? 1, 0, 1, 0. Sorry, it is 10. No. 1, 0, 0, 1, 0 is equivalent to the 20. See, last one is 16. 8, yeah. Correct? Yes. Next. 12. 12 means what? 8 plus 4 is going to be 12, right? So 0, 1, 1, 0. So this is. The last is going to be kept as a weightless, which is a 0. Now, if we perform the exclusive operation, what? 8421, right? Like 0 1 1 0 0. Right. Now, what we are doing? When the inputs are similar, false as an output. When the inputs are dissimilar, true as an output. Now, inputs are similar, right? 0 0 is same. Therefore, 0 will be the output. Inputs are same, 0 will be the output. Inputs are same, 0 will be the output. Inputs are different, 1 1. Now, what is the output here? Obviously, 1 1 0 0 is equivalent to what? 16 plus 8, 24. You see the output now? We need not to be bothered about it. We can able to execute such way that this program will be gives the output to you. So, sorry, we haven't performed the operation, right? Print email ID, email, exclusive operation, password. 24. So in the network, it will be going 1110000, which is equivalent to 24. This is how exclusive operator is going to be take the logical output and it will be produced. But hacker cannot understand which operator you are using combinationally to perform the encryption and decryption process. Are you clear? మనం ఇవి తెలుసుకోవాలి. బట్ లోపల మనం అల్గారిథం రాసినప్పుడు బిట్వైజ్ అండ్ ఆర్ ఎక్స్క్లూజివ్ అన్ని చేయొచ్చు. చేసిన తర్వాత ఎన్క్రిప్షన్ చేయొచ్చు. ఏం చేస్తున్నారు అనేది హ్యాకర్కి అర్థం కాదు లోపల. ఆర్ యు క్లియర్? So next is that there is an operator is demo about left shift operator, bitwise operator. Left shift bitwise operator. What is that left shift operator? This will be the yeah, this is left shift operator. So what a left shift operator, let me tell you. Left shift operator on alternate to the multiplication operator. Let's take x is equal to 10. Now print x into 2. What is the output you are going to get? 20. The output is what? 20. Even though print x left shift 1, it is also give you the 20 same only the result. You see the output? So according to the scientifically observation that applying the multiplication operator is little tough or tedious job to the arithmetic logic unit, rather than the shifting the value at a binary level by moving left or right will be very easier job for the computer. Wherever you will be required the multiplication operator to perform binary weightage level, which means x into 2 is 20. X is left shift 1 time is 20, right? Now we can perform 4. Left shift 2 times. Same. Performing a particular value by 8, left shift 3 times is also the same. Clear? నువ్వు మల్టిప్లికేషన్ ఆపరేటర్ ఇచ్చేయాలా లేదనంటే లెఫ్ట్ షిఫ్ట్ ఆపరేటర్ ఇచ్చేయాలని నీ ఇష్టం. అది ఎలా జరుగుతుంది లోపల? లెట్స్ టేక్ వన్ ఎగ్జాంపుల్. లెట్స్ టేక్ వన్ ఎగ్జాంపుల్. ఇక్కడ మనం 10 తీసుకున్నాం. 10 యొక్క బైనరీ వాల్యూ ఏంటి? 1 0 1 0. This is the binary value. If you left shift once, the value would be come to here. So these are the memory blocks. Clear? ఇప్పుడు ఈ 1 ని ఒక్కసారి లెఫ్ట్ షిఫ్ట్ చేస్తే ఇక్కడికి వస్తుంది 1. ఈ 0 ఈ పొజిషన్ లో వస్తుంది, అంటే ఇక్కడ వస్తుంది. కరెక్ట్? అండ్ this 1 will come to here. Clear? And this particular 0 will come to here, which means here. So ఇది లేదు యాక్చువల్గా, బట్ ఇది వేకెంట్ అవుతుంది. దీని యొక్క పొజిషన్ ఏదైతే ఉందో ఇది వేకెంట్ ఉంది. అకార్డింగ్ టు ఎలక్ట్రానిక్స్ అజంప్షన్, whatever the place is going to become vacant after moving, shifting the values, explicitly we are going to be pushed with a 0. అప్పుడు ఈ 10 will become a 20. 10100 will be become equal to 20. ఒక్కసారి లెఫ్ట్ షిఫ్ట్ చేస్తే, 2 సార్లు లెఫ్ట్ షిఫ్ట్ చేస్తే ఈ 1 కాస్త ఇంకొక పొజిషన్కి వెళ్తుంది 1. 20 will become 40. ఇంకొకసారి లెఫ్ట్ షిఫ్ట్ చేస్తే 40 will become 80. 80 will become 160. 160 will become 320. Like that, a value will be keep on changing. The point is that here, not. If you want to multiply a value in the series of binary weightage, then better replace left shift operator instead of multiplication. Clear? ఎక్కడైతే మల్టిప్లికేషన్ ఆపరేటర్ యూజ్ చేస్తావో నువ్వు, ఒకవేళ నువ్వు మల్టిప్లై చేయాల్సిన అవసరము 2, 4, 8, 16, 32, 64, 128 ఇలా ఎక్కడైతే ఆ పాసిబిలిటీ ఉందో అక్కడ మల్టిప్లికేషన్ ఆపరేటర్ని రీప్లేస్ చేసి లెఫ్ట్ షిఫ్ట్ ఆపరేటర్ని యూజ్ చేస్తే సైంటిఫిక్గా అర్థమెటిక్ లాజిక్ యూనిట్ యొక్క బర్డన్ని మనం తగ్గించినట్టు. దట్స్ ద పర్పస్ ఆఫ్ ది left shift operator. Are you clear? Great. Now, there is another operator is that demo about right shift, right, which is this operator. Right. This operator is alternate to the division operator. Let's see. Y is equal to 20. Print y divided by 2. Print y right shift 1. Correct? You see the output? ఒక వాల్యూను డివిజన్ తో 2తో చేసినా ఒకటే, రైట్ షిఫ్ట్ చేసి ఒక్కసారి చేసినా ఒకటే. సిమిలర్లీ యూ కెన్ పర్ఫార్మ్ 4 అంటే ఒక వాల్యూని 4తో డివైడ్ చేసిన 2 times రైట్ షిఫ్ట్ చేసిన సేమ్ రిజల్ట్ ఈస్ గెటింగ్ ప్రొడ్యూస్డ్. క్లియర్? సో the purpose of the right shift operator is that when there is a binary weightage series is going to be divisible for a particular value, straight away you can replace the division operator by the right shift operator. This is an alternative. Lastly, we have that 2's complement operator. 2's complement. Clear? Tilde operator. What is a 2's complement operator? This operator is called tilde operator. Clear? Now, what exactly it will be doing? A is equal to 10 I'm going to give. Clear? The output will be produced. 2's complement of A is going to be a minus 11. You see the output? ఎట్లా వచ్చింది ఇది? 2's complement అంటే మీనింగ్ ఏంటి? 10 యొక్క ఈక్వలెంట్ వాల్యూ ఏంటి? 1 0 1 0. It is the equivalent binary value for the 10. If you perform the 2's complement means LSB, ఈ బిట్ ని LSB బిట్ అంటారు, లీస్ట్ సిగ్నిఫికెంట్ బిట్ అని అంటారు. ఈ 1 ని మోస్ట్ సిగ్నిఫికెంట్ బిట్ అంటారు. దీన్ని రైట్, దిస్ వాల్యూ విల్ బి LSB. This is going to be a MSB. Yes or no? ఈ లీస్ట్ సిగ్నిఫికెంట్ బిట్ అనే ప్లేస్ లో ఒకటిని నువ్వు యాడ్ చేస్తే దీన్ని 2's complement అంటాం మనం. సో 0 + 1 is 1, 1 0 1. According to electronics assumption, the last bit MSB bit is 1, it is a negative value. 0 ఉంటే దాన్ని పాజిటివ్ వాల్యూ అంటాం. The value 1011 will be equivalent to 11 బైనరీలో. 1011 is 11. Because of the 1 is the most significant bit is 1, we prefixed with a minus. This minus 11 is this. Are you clear? This is the purpose of the 2's complement operator called as a tilde operator. Swarup, are you clear?
Yes, sir.
Yeah. This is how the things would be happening. Yes or no? So with this, all the operators are finished. What are the operators we have? We can go up. So here we have started logical operator. Before that, I spoken about arithmetic operators. I spoken about relational operators too. Logical operators, obviously assignment operators, bitwise, membership, identity, and all the operators have completed, isn't it? So you just please, try to be, I have sent you 35 questions to you. I think some more questions are belonging to bitwise operators. Some more questions are belonging to membership operators. Whether you have done or not, I need please you guys to be completely go through those questions. Like, I have sent you through WhatsApp. Swarup, have you seen?
Day before yesterday, some
Yes, I
document.
have sent you assignment questions. Like, let me show you where exactly it is.
Yeah, update the questions. Yeah, I see.
Correct. So here, if you go here, కొన్ని questions అవి అన్ని for example, identify invalid keyword. Obviously, keyword అంటే ఏంటంటే already predefined keyword. While is predefined keyword, and is predefined keyword, and as is also predefined keyword, but until is not predefined condition. And similarly, if you go down, I think 1 is greater than 2 and 9 is greater than 6 is a relational operator. Comes back. If you go down, yeah, the 1's complement of 60 is that 60 ని బైనరీలోకి చేంజ్ చేసి, isn't it? దాన్ని మనము దాని యొక్క ఈక్వలెంట్ వాల్యూ చూస్తే మనకి దీంట్లో ఈక్వలెంట్ వాల్యూ వస్తుంది. టిల్డ్ ఆపరేటర్ అప్లై చేయండి దీనికి, అప్పుడు -61 వస్తుంది ఆన్సర్. నో. ఇది ఏమవుతుందంటే వాడు టెక్స్ట్ బుక్ లో ఇవ్వడం 1's complement ఆపరేటర్ అంటాడు టిల్డ్ ఆపరేటర్ ని, కానీ లోపల జరిగేది 2's complement ఆపరేషన్. 1's complement కాదు. అలా అయితే 1010కి ఏమొస్తుంది అవుట్పుట్? 0101 వస్తుంది, విచ్ ఇస్ ఈక్వల్ టు 5. కానీ అవుట్పుట్ -11 వచ్చింది కదా. ఎస్. సో ఇన్ అ సిమిలర్ వే, కాంప్లెక్స్ వాల్యూస్ ఉన్నాయి. ఐ థింక్ సో ఇండెంటేషన్ ప్రాబ్లం అంటే ఏంటి, many things are there. Please you go through that. Exclusive యొక్క పర్పస్ ఏంటి, బిట్ వైజ్ Which operator gives 1 if the bit is 0 and other is 1? Obviously, XOR operator is the answer. Yes or no? సో వాడు రివర్స్ లో ఇచ్చాడు మనకి. చాలా ఉన్నాయి ఈ క్వశ్చన్స్ లో, ప్రాపర్ గా చూసుకొని మీరు కరెక్ట్ గా ఇంతవరకు చెప్పిన ఈ ఆపరేటర్స్ అన్ని, ఈ పర్టికులర్ క్వశ్చన్స్ అన్ని యూస్ఫుల్ అవుతున్నాయి లేదా చూస్తాను. అండ్ అపార్ట్ ఫ్రమ్ దిస్ ఐ విల్ సెండ్ యూ ది అసైన్మెంట్ క్వశ్చన్స్ రిలేటెడ్ టు ఆపరేటర్స్. Are you clear? So please go through this, and I need a understanding of all the questions properly. Are you clear? Yes. So tomorrow I'll be going to start the control statements. If you are completed, right, looping statements, special statements, all those we are going to be discussed. Yeah.